For centuries, humans have gazed at the stars and dreamt of exploring the cosmos. The night sky, with its myriad of twinkling stars and mysterious planets, has always been a source of wonder and inspiration. Early astronomers, with their rudimentary telescopes, laid the groundwork for our understanding of the universe, sparking a curiosity that has only grown with time. Among the countless celestial bodies, one stands out as a particularly tantalizing target for our extraterrestrial ambitions: Mars. This red-hued planet, visible even to the naked eye, has been a focal point of both scientific study and popular imagination. Its distinct color and surface features have made it a subject of fascination and speculation for centuries. The Red Planet, as it's aptly nicknamed, has captivated our imaginations for generations, fueling countless science fiction stories and inspiring real-world scientific endeavors. From H.G. Wells' The War of the Worlds to modern-day blockbusters, Mars has been depicted as a land of mystery, danger, and potential. These stories, while fictional, have often been rooted in the real scientific possibilities that Mars presents. But why Mars? Why journey millions of miles to a desolate and unforgiving world? The allure of Mars goes beyond its striking appearance. It represents a new frontier, a place where humanity can test its limits and expand its horizons. The challenges posed by Mars are immense, but so are the opportunities for discovery and growth. The answer lies in a unique combination of factors that make Mars the most promising candidate for human colonization. Unlike our own moon, which lacks an atmosphere and is bathed in harmful radiation, Mars possesses a thin atmosphere, albeit 100 times thinner than Earth's. This atmosphere, while not breathable for humans, does offer some protection from solar radiation, making it a slightly more hospitable environment. This atmosphere, while not breathable for humans, does offer some protection from solar radiation. It also allows for the possibility of weather patterns, albeit much weaker than those on Earth. The presence of an atmosphere means that Mars experiences seasons, winds, and even dust storms, adding to its dynamic and intriguing nature. More importantly, Mars is rich in resources crucial for human survival. The planet's surface is covered in a variety of minerals and elements that could be harnessed for building materials, fuel, and other necessities. The potential for in-situ resource utilization is a key factor in making Mars a viable destination for long-term human presence. Evidence suggests the presence of water ice beneath its surface, a vital ingredient for sustaining life. Water is essential not only for drinking, but also for growing food, generating oxygen, and producing fuel. The discovery of water ice on Mars has been a game-changer, opening up new possibilities for human exploration and settlement. The Martian soil, though lacking in organic matter, could potentially be enriched to support plant growth. Experiments have shown that with the right nutrients and conditions, it might be possible to cultivate crops on Mars, providing a sustainable food source for future colonists. This ability to grow food locally would be a significant step towards self-sufficiency. And let's not forget the planet's proximity to Earth. Relatively speaking, of course, Mars is the closest planet to Earth that offers the potential for human habitation. Its distance, while still vast, is manageable with current and near-future space travel technologies. This proximity makes it a more practical target for exploration and colonization compared to other planets or moons. While a journey to Mars would still be a monumental undertaking, it's far more achievable than reaching other potentially habitable worlds in our solar system. The technological advancements required to reach Mars are within our grasp, and the journey, though challenging, is feasible with sustained effort and investment. Mars represents a challenge, a frontier that beckons us to push the boundaries of human ingenuity and daring. It is a test of our ability to adapt, innovate, and overcome obstacles. The pursuit of Mars is not just about reaching a new destination, it's about proving what humanity is capable of achieving. It's a chance to establish a second home for humanity, a backup plan for our species in the face of potential threats to Earth. Whether it's climate change, natural disasters, or other existential risks, having a presence on Mars could provide a safety net for the future of human civilization. It's a stepping stone to further exploration of the cosmos, a launching pad for future generations to venture even deeper into the unknown. Mars could serve as a base for missions to the outer planets, asteroids and beyond, expanding our reach and understanding of the universe. The journey to Mars will be fraught with difficulties, but the potential rewards are too great to ignore. The challenges we face in reaching and colonizing Mars will drive innovation and progress, leading to new technologies and solutions that could benefit all of humanity. The dream of Mars is not just about exploring a new world, it's about pushing the boundaries of what is possible and inspiring future generations to reach for the stars. While the prospect of colonizing Mars is undeniably exciting, it's crucial to acknowledge the harsh realities that await us on this alien world. The red planet, with its captivating landscapes and potential for discovery, also presents a myriad of challenges that we must overcome to make human habitation a reality. Mars is not for the faint of heart. Its rugged terrain and barren landscapes are just the beginning of the obstacles we face. Its environment is unforgiving, characterized by extreme temperatures, a thin atmosphere, and constant bombardment from harmful radiation. These factors create a hostile environment that requires advanced technology and innovative solutions to ensure human survival. Surviving on Mars will require overcoming these challenges with innovative solutions and unwavering determination. Engineers and scientists are already hard at work developing the necessary technologies to make this possible. Let's start with the temperature. The average Martian temperature hovers around a bone-chilling -80 degrees Fahrenheit or -62 degrees Celsius. This extreme cold poses a significant threat to human life and requires robust heating systems to maintain habitable conditions. That's cold enough to freeze carbon dioxide into dry ice, which forms a significant portion of the Martian polar ice caps. These ice caps are not only a testament to the planet's frigid climate, but also a potential resource for future colonists. To survive in such frigid conditions, Martian colonists will require specially designed habitats that provide insulation, heating, and protection from the elements. These habitats must be capable of withstanding the harsh Martian winters and maintaining a stable internal environment. Then there's the atmosphere, or lack thereof. Mars' atmosphere is composed primarily of carbon dioxide, with only trace amounts of nitrogen and oxygen. This thin atmosphere means that humans cannot breathe the air on Mars and must rely on life support systems to provide the necessary oxygen. Not only is this thin atmosphere unbreathable for humans, but it also offers little protection from solar and cosmic radiation. The lack of a substantial atmosphere means that harmful radiation from the sun and deep space can easily reach the Martian surface. Martian colonists will need to live in sealed habitats or wear pressurized suits whenever they venture outside. These suits and habitats must be designed to protect against the harsh environmental conditions and provide a safe living space. Speaking of radiation, that's another major challenge posed by the Martian environment. Unlike Earth, which is shielded by a strong magnetic field, Mars has a weak magnetic field that offers little protection from harmful radiation from the sun and deep space. This lack of protection increases the risk of radiation exposure for anyone on the Martian surface. Prolonged exposure to such radiation can lead to various health problems, including cancer and radiation sickness. This makes radiation shielding a critical component of any Martian habitat. Martian habitats will need to be designed with radiation shielding to mitigate this risk. Engineers are exploring various materials and designs to create habitats that can effectively block harmful radiation and ensure the safety of the inhabitants. Water is the lifeblood of our planet, and it will be equally crucial for sustaining human life on Mars. The quest for water on Mars is not just a scientific endeavor, but a necessity for the survival of future Martian settlers. Fortunately, there is evidence to suggest that water exists on the red planet, hidden beneath its surface and in its polar ice caps. Albeit not in the same abundance as on Earth, the Martian landscape with its dry riverbeds and ancient lake beds tells a story of a planet that once had flowing water. Finding and utilizing this Martian water will be essential for any successful colonization effort. Scientists are working tirelessly to understand the distribution and accessibility of water on Mars. Scientists believe that vast quantities of water ice are locked beneath the Martian surface, particularly in the planet's polar regions. These regions, covered in thick layers of ice, could be the key to sustaining human life on Mars. These icy deposits could provide a valuable source of water for drinking, agriculture, and even rocket fuel. The ability to harvest and utilize this water will be a game changer for long-term missions. Extracting this water, however, will require developing innovative technologies capable of drilling into the Martian crust and processing the extracted ice. Engineers are designing specialized equipment to tackle this challenge. In addition to subsurface ice, Mars also possesses water in the form of hydrated minerals present in its soil. These minerals contain water molecules trapped within their crystal structure. This form of water, though more difficult to extract, represents another potential resource. While extracting water from hydrated minerals is more challenging than tapping into subsurface ice, it offers a supplementary source of water that could be crucial in emergencies. It's another potential source that could be exploited with the right technology. Researchers are continuously testing and refining methods to make this extraction process more efficient. Once extracted, Martian water will need to be purified and treated before it's safe for human consumption. This will involve removing impurities like salts, perchlorates, and heavy metals that could be harmful to human health. The purification process is critical to ensure the safety and well-being of astronauts and heavy metals that could be harmful to human health. Advanced filtration systems will be necessary to make Martian water potable. Fortunately, NASA and other space agencies are already developing water purification systems for use in space, which can be adapted for Martian conditions. These systems are designed to handle the unique challenges posed by the Martian environment. And these technologies could be adapted for Martian conditions. The future of human life on Mars hinges on our ability to harness and utilize the planet's water resources effectively. Growing food on Mars will be another critical aspect of establishing a self-sustaining human presence on the red planet. The Martian soil, while lacking in organic matter, possesses some of the essential nutrients plants need to grow. However, it also contains high levels of perchlorates, toxic salts that can be harmful to plants and humans alike. Overcoming these challenges will require ingenuity and a deep understanding of plant science. One promising approach to Martian agriculture involves cultivating plants within controlled environments like greenhouses. These greenhouses would provide plants with the ideal conditions for growth, including controlled temperatures, artificial lighting, and a nutrient-rich hydroponic solution. By carefully managing the growing environment, Martian farmers could potentially cultivate a wide variety of crops, from staple foods like potatoes and wheat to leafy greens and even fruits. Another approach involves developing methods to remediate the Martian soil, making it more hospitable to plant life. This could involve introducing beneficial microbes that break down perchlorates and other harmful substances, enriching the soil with organic matter, and adjusting its pH to a level suitable for plant growth. While soil remediation is a long-term solution, it holds the potential to transform the Martian landscape into fertile ground capable of supporting a thriving ecosystem.